Let's look at 3.3, truth tables for negation, conjunction, and disjunction. We are going to use definitions of these terms, construct truth tables, and determine the truth value of a compound statement for a specific case. So here's a truth table for negation. So if P is true, then not P is false. If P is false, not P is true. Remember, conjunction is the and statement. In order for a P and Q to be true, both have to be true. So P is true, Q is true, so P and Q is true. P is true, Q is false. P and Q is false. So I'm going to write the and between these. They both have to be true in order for P and Q to be true. So this is the only one that's true because they are both true. Let's look at some specific statements. We have that P is 10 is greater than 4. That is true. Q statement, 3 is less than 5. That is true. Determine the truth value for each statement. So P and Q. So they're both true, so this is true. Since both are true, the conjunction is true. The next one is not P and Q. So if P is true, then not P means 10 is not greater than 4, which that is false. So not P is false. Q is true. They both have to be true in order to be true. So this is a false statement. Let's look at the next one. We have 7 plus 2 equals 8. That is false. 10 times 7 is 70. That is true. This statement is what we're going to find the truth value of, not P and Q. So not P means 7 plus 2 is not 8. And that is true. So 7 plus 2 does not equal 8. So that makes it true. So now let's look at the conjunction of this. So not P is true. Q is true. So the truth statement is true. Or the statement is true. Truth value. The next one, let's fill in this table. So we have P is true, Q is true. So now let's fill in the not Q. So if Q is true, then not Q is false. If this is false, then this is true. They're always opposite of each other because that's the negation. So this would be false, this would be true. So now we want to look at P. So we're going to look at P and not Q, or negation of Q. Remember with the and statement, they both have to be true. So true and false, so that's false. True and true, that is true. False and false, false. False and true, false. So the only one that is true is when P is true and the negation of Q is true. Let's look at disjunction. Only false when both complement and statement are false. So remember, this is the or statement. So it's true unless both are false, then it's false. So if both are false, then P is false. P or Q is false. See how I wrote it, if then statement. All right, so if P is true, Q is true, P or Q is true. True, false, it's true because it's the or. So you could write over here, or. False or false means the whole thing is false. Okay, so let's look at some disjunction examples. So this is similar to what we did earlier. 10 is greater than 4. That is true. 3 is less than 5. That is true. So let's look at the negation. So this one has the negation of Q. So let's do the negation of P and the negation of Q. So this means 10 is not greater than 4, and that is false. 3 is not less than 5, that is false, so they're both false. So let's look at P. P is true, or this one is false. So as long as you have one that's true, it's true. Next one, not P, is false, or not Q is false. So false or false, that's going to make it false. When they're both false, it's false. Constructing a truth table. So let's look at this. We have P and Q already listed out, and that's kind of like your given. Now when we're doing something like this, the negation of P or Q, then we need to first find P or Q, which is right here. Or is that and? That is and. Yeah, that's an and. P and Q. So we would look at this. True and true, make it true. True and false, make it false. False and true, make it false. False and false, make it false. So remember, with and, both have to be true. That is the and. The or is the other one. So now we're going to do the negation. So when we do the negation of this, we're just going to look at this. We've already found P and Q. So now we're going to negate P and Q. So we're going to do the complete opposite. So false, true, true, and true. What about whenever we have three statements? So we have P, Q, and R. This is how you would do your truth table. So we're going to use this truth table on this example right here. So construct a truth table for the following statement. I study hard and ace the final, or I fail the course. So we have a first statement, I study hard. And if you look down here, it says P. P is I study hard. And, so the upside down V, I ace the final, so that's Q. Or, so this has to be in parentheses, or I fail the course. Okay, so let's go through, and first thing we want to do is this in parentheses. So P and Q. So remember, with P and Q, they have to both be true. So P and Q, true, that's false. False, 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 and false. Okay, so now we are going to do this. So P and Q or R. So remember, with the or statement, we are going to look at basically these guys now for this. So with the or statement, as long as it's not both false, then it's a true statement. So true, true is true. False, true is true. True, false, true. False, false, that is a false because it's the or statement. True, false, false, false. True, false, false, false. So we have completed the table. So let's answer part B. Suppose that you study hard, you do not ace the final, and you fail the course. Under these conditions, is this compound statement true or false? So let's break it down. You study hard. So we're saying you study hard is true. You ace the final. Well, this says you do not. So this is a false. I fail the course. You fail the course. True. So we are going to look at when P is true, Q is false, R is true. So let's see. P is true, false, true. So it's these. So let's see, what is the truth value? It is true. So that is how you would complete the entire truth table and then look for a specific situation. All right, this next one, determine the truth value for the statement below when P is true, Q is true, and R is true. So we have this compound statement. So instead of creating the entire truth table, we can just create one row. So I'm going to do P, Q, and R. And then, because I need a negation of P, I'm going to do negation of P. Then I'm going to do negation of R, because I'm going to need that also. Then I'll do this compound statement, Q or negation of R. And then I'll do the entire thing, negation of P and Q. So what I'm doing is finding all the little pieces that I might need. So these are my given. I have to have these down. So then the next thing is I know I need a negation of P. I know I need a negation of R. Then I need this statement, Q or negation of R. Then my final step would be the entire statement. So they've given us the truth value for the statements. So this is true, true, and true. That comes directly from the given. Now, using the given, we're going to fill in the rest of the table. Negation of P. Well, if P is true, negation would be false. Negation of R. If R is true, negation is false. Now let's do Q or negation of R. So let's look at, here's Q, here's negation of R. So with the or statement, the only way it's false is if they're both false. So we have one that's true, so that makes it true. Now let's do this one. This is a and. So negation of P is false. And true. And means they both have to be true. So this isn't false. So this statement is false. So remember, and both have to be true to be true. Determining truth values for specific cases. We can determine the truth value of a compound statement for a specific case in which the truth values of a simple statement are known without constructing an entire truth table, just like we did here. And you'll substitute the truth values for simple statements into symbolic form of the compound statement and use appropriate definitions to determine the truth value. So that's what we did here. So there'll be a few problems that you'll need to do like that. So let's look at this final example. The line graph to the right shows the average gas prices of a country from 1980 through 2005. Let P, Q, and R represent the simple statements. So let's find the truth value for the simple statements first. Prices peaked at 2000, year 2000. Yeah, that does peak. So let's say that's true. Prices remained steady from 1985 to 1990. Here's 1990, so this would be 85. They're pretty close. So that would be like 225 up to 250. So I would say true. Prices were less than 250 in 1985. Well, this would be 250. 1985, that would be true. So they're all true statements. So let's go ahead and make our little table, P, Q, and R. And then let's see, what do we need to do? Write the symbolic statement P and Q or R in words. Then use the information given by the graph to determine the truth value of the statement. Okay, so P is true, Q is true, R is true according to our graph. So we already have P, so we need to do Q or R. Well, Q or R, they're both true, so it's true. And then we would need to do the entire thing. So in order for an and statement to be true, they both have to be true. So P is true and Q or R is true. So this is true. So the statement is true. So now we just need to see the statement in words. So it says P and parentheses. So P is prices peaked. So let's look at our answer choices. Prices did not peak. Nope. Prices peaked. That's good because that is P. Prices peaked. That is P. Prices did not peak. That is not it. Then it says and. So it should say comma and because of the parentheses there. Prices remain steady. Prices remain steady. That would be a true Q, which is what we have. Prices did not remain steady, so that's doing like that instead. It's a negation, so that's not it. Now let's just double check. Or prices were less than $250. That would be R. There we go. See, that's a statement written in words. So that is the correct answer. And it says also determine the truth value. Truth value, we were able to find it using the table. That is it for the day.